Hello and welcome back to my devlog. This is the second entry where I am developing a remake for this game, Magic Carpet 2001. So you probably know this game from the Caltron 6-in-1 mode cartridge, an unlicensed game released in North America from a company in Taiwan. But actually, as I promised, here is the physical cartridge released in Asia. I actually have the box as well, so here. So this is proof that this game had a life of its own. So while North America was getting the Caltron 6-in-1 cartridge, the rest of the world, basically Latin America, Brazil included, and Asia, they were getting this guy. Physical release, single game. We are remaking it. Now, Magic Carpet 1001 will become 1001 Nights in Magic Carpet Remake. And the first step of doing this remake is porting the original code from its original mapper to a new one that we can benefit from more graphics and more space for programming. So very quickly, what is a mapper? The original NES could only see a block of 32 kilobytes of program memory, this lives on the ROM chip, and 8 kilobytes of graphics. That's it. So if you open Super Mario Brothers, for instance, that's everything you're going to see. And I can show you guys that. I developed a few tools of my own. This is the original ROM, and here you can see the original game. These are the program banks, 32 kilobytes. So you can imagine a line, splitting them in two here at the middle. And then you would have 8 kilobytes, 8, 8, and 8. So 4 times 8, 32 kilobytes of program memory. And the graphics are all organized in one single 8 kilobyte bank. We call these banks, by the way, memory banks. So the character ROM is connected to the PPU, which means it has all the graphics of the game, and the program ROM is connected to the CPU, so it contains the program, the logic of the game. Let's take a look at the original Magic Carpet. So here you can see the same two program banks. So 32 kilobytes of ROM is allocated for the game, but when we take a look at the graphics, there are actually two banks. So this game, despite being really simple, it uses more graphics than the NES was originally designed to use. And the way it does that is by using a memory mapper, which basically means that the PPU, so the picture processing unit of the NES, continuously look into this area of memory, but instead of this being a physical block of memory, it's just a logic window, and you can point this window to a physical block of memory. For instance, you can point it to the first one like this, and then the game would see only these graphics, but you can also point it to the second bank, and the game would see these graphics instead. The whole window can show the whole block. It doesn't matter which one. And you can change this on the fly. And actually, this happens really fast, this change. So fast, in fact, that games like Prince of Persia could use this to animate the character. So each frame of animation of the Prince of Persia character in the NES lives in a different bank. And from one frame to the next, the mapper changes, it bank switches which bank is shown on the graphics window, so you can animate the character. It's something that happens really fast. But this is limited for us because I want to be able to store richer music, cutscenes, more logic for the game. And as you can see, the program ROM is already full, and the original bank, it does accept more graphical banks, but it doesn't accept more program banks. We will fix that. In fact, we need something called an MMC3 mapper. This is one of the most common mappers on the NES. Games like all of the good Capcom games, like the DuckTales games, or all of the Disney games actually, and Mega Man, all of those use MMC3. Also a few of the Konami games use them too, before Konami developing their own line of mappers. But in any case, what do we gain by making the game compatible with this mapper? First of all, this mapper has been extensively studied and reverse engineered, so we do have a modern day replacement for it. We can make games and put them on cartridges by programming them as if they were using the original MMC3 chip. This is possible. There are other games that use more advanced mappers, but we couldn't put them on cartridges, at least not right now, not with the current technology anyway, because we don't understand these mappers very well, the MMC5 and 6 for instance. Now, what this mapper gives us in terms of quality of life improvements. So first of all, it gives us a lot more space. So we can have up to, instead of 32 kilobytes of program ROM, we can have up to 12 kilobytes of program ROM. And instead of having this configuration with two banks like this, we actually, so picture this. The last bank representing 16 kilobytes, it's always fixed. So when you boot up the console will always be able to find whatever is in these addresses, and no matter the state of the mapper. But the first two 8K banks, so picture the 16 kilobyte column here, split them in half. Each one of these halves have 8 kilobytes. These are just windows, and we can point them anywhere on the larger pool of memory banks that we want. So we can swap them, we can bank switch them. This means we can have more code running. At a time, the NES still is only capable of addressing code that lives in this window, but think of this like files in a modern game. It's like I have different files with different logic parts of the game, and I can load them into memory. It works exactly like that. And we can do the same for graphics. So using MMC3, instead of having the original only 8 kilobytes of memory, we can go up to 256 kilobytes. And the graphics window, the bank window, so picture this only column, this is 8 kilobytes. The first half of it is split in two banks of 2 kilobytes each, and the second half is split in 4 banks of 1 kilobyte each. And we again picture these as files, and we can load and unload them any way we want. So in order for us to be able to do this, we need to intercept every call originally meant for the original chip, the original mapper, and change it to a call to the new mapper, to the MMC3. So by doing that, we can make the original game work exactly the same, but now it would work in a new mapper. And that's the start of our project. And in fact, I already did this 2 years ago, when I started everything before disassembling the ROM. So just looking at the binary data of the original game, I changed a few functions around so we could have more space in the bank. And I used part of this space that you see down here, this free space. And I did change the calls to an MMC3, and it works. So you can see this by going into romhacking.net and looking for Magic Carpet 1001. You see a few hacks here, 2 translations, and 1 hack that says MMC3 Port. So this is it. If you go here, you see Binary Lab, that's me, and a short description of the changes that I made. These are the minimal changes that I could do to preserve the game, the original game, but make it compatible with the MMC3 mapper. So if you apply this patch to the original ROM, you have a game that can run on MMC3. So this is where we start, and this is where we end today's entry of my devlog. Next one, I want to show you the proof of concept for the scrolling levels with the new art. Don't miss it. See you then!